So I'm just going to say a few words about GCEP for those not familiar with the program. First of all, thank you all for coming. We have over 90 people registered today, and I imagine that the room will fill up throughout the day. But for now, so the Global Climate and Energy Project started about 10 years ago. And it really came out largely because of a recognition for a need for sufficient and sustainable energy supply to meet the needs of our growing population over the coming decades. So in order to meet this demand, it was recognized that new ideas and energy technologies would be needed. Do we have it on the screen here? So GCEP really started out with three main goals. One was to discover new scientific concepts for clean energy. Another was to develop breakthrough energy technologies. And the third, and perhaps one of the most important, was educating the future energy thought leaders and research workforce. So GCEP is really focused on fundamental research. And by this we mean research that goes before anything that startup companies would do, anything that industry would do, and it's really in the fundamental stages. And we fund research across the board in different areas, including photovoltaics, bioenergy, grid storage. And with these projects, we hope that new technical directions will be opened up. We got it? Great. So I talked over this, but this is the one I really wanted you to see. So this is where GCEP fits in the landscape of R&D and industry, right at the very start. So any ideas and fundamental research that comes out of GCEP, we hope will eventually go on to be worked on further in startup companies or in industry. GCEP is supported by 5 sponsor companies now, ExxonMobil, Schlumberger, Toyota, GE, and recently joined DuPont. So far, we've funded about $121 million worth of projects. With that, 157 faculty around the world are involved. And we also have the advantage of the world-class facilities at different research institutions based on this diversity. And there's some 20 or so in the US and fast approaching that number worldwide. So this is our project portfolio. And as you see, we fund across many areas: electrochemistry, electric grid, from grid-scale storage to batteries, carbon-based energy systems, which include CO2 capture and storage, and then bioenergy systems, which includes modification of feedstocks and assessment of the biomass domain. And we have many projects in solar photovoltaics that cover nearly all types of solar cells. So just as an example, one of the fundamental science projects is related to this cathodic biofuel reactor. And this impacts many areas of the portfolio, but really it's focused on understanding the mechanisms that these microbes can use to take electrons from renewable sources and turn that into some kind of fuel. In addition, we also do some work on combustion, and so I should mention, actually, this is Alfred Sporman's work, and I think he might be attending today, so please do speak with him if you can. Another work is by Chris Edwards, and it's on aimed at high efficiency engines, and it's looking at high temperature and high compression ratios. And I think Chris might also come today, so you can always chat with him to find out more. And then in the CO2 sequestration area, we're looking at the fundamental processes for CO2 mineralization. So looking at the kinetics of this with different organic acids. And that is Kate Maher, who's also at Stanford. So how do we recognize, how do we identify those areas? Well, one of the roles of this workshop is to do just that. Analysts that work at GCEP. That's Emily Hung and myself, and the theme leaders. So Chris Field is one of those, and Sally Benson, Richard Sassoon, managing director. We're really the technical leads in deciding what areas to go forwards in research. And so this workshop is a way to generate ideas, identify opportunities, and identify any key areas where fundamental research can overcome barriers to deployment of certain energy technologies. And sometimes these workshops can lead to calls for proposals in a certain area, and this goes worldwide. And that was just one example there that happened about 4 or 5 years ago in the lignin area, aimed at the conversion efficiency, essentially, of biomass by reducing or changing lignin composition. So for today, we have 4 main topic areas, very diverse, from looking at the feasibility of BECCS, the impacts, what barriers there are to global deployment, to maybe some of the restrictive parts of that, which are biomass supply. And then looking at the conversion and storage technologies and figuring out what's perhaps the best way for conversion. And also storage capacity. Are there enough storage sites? What are the costs? And then looking at a slightly different aspect than BECCS, addressing other contributions to carbon emissions. So methane is a particularly strong climate-forcing greenhouse gas. So thinking about ways to target emissions from significant sources there. And then lastly is system modeling, thinking about what scenarios would be best to help us reach negative emissions globally. And can we do that without BECCS? And so we also have a breakout session later in the day, and the questions for that are at the back of the program, and those serve as discussion points only. And I'll show this much later in the day, closer to the session. And lastly, but not least, lunch will be on the second floor terrace, which is between this building and Y2E2. All right, thank you. I'll hand it over to Sally.